Hello guys, and welcome back to IV Twitter. My name is Ed, and we are going to be looking at the singleton design pattern in this video. So the singleton design pattern is actually one of the easiest to understand because it only involves one class, which means there aren't a lot of moving parts. And just forgive my voice, not that well. But yeah, so that is the singleton design pattern. It only involves one class, and you use it mostly when you want to restrict the number of instances on a class. So you realize that in most cases, it's only going to be one instance, but you can also use it to to limit how many instances you want. So it's not always going to be one instance. I'm saying this upfront because I've seen exam questions where they ask you how you would manipulate the singleton design pattern to suit a scenario where you want maybe a defined number of instances. Okay, so we'll look at those examples when we look at past exam papers. But basically, to do the singleton design pattern, you're just going to do three things, right? The first thing you're going to do is making the constructor private. The second thing is, once you make the constructor private, this means that outside of this class, it's now impossible to create an instance of this class. So the instance can only be created within this class. Okay? So once you do that, the second thing that you want to do is you then create an object that you use to store the instance within that class. So you create a pointer that stores that one instance, right? And then the third thing that you do is you then create a function that you then use to expose that instance. And we're going to do a quick demonstration of how this is done in code, right? Okay. So let's say you are given a class solo, like in this example. I want you to understand that when you are applying the singleton design pattern, you don't care about everything else that is happening in that class. You don't care about the other functions, the other data members. Your focus is strictly on these three things, right? So what do you do? Number one, you said hide the constructor. In other words, you put the constructor under private, right? Once you have done that, that means no one can make an instance of solo. It becomes impossible anywhere in your program to do something like solo s, because this line here requires access to the constructor of solo to make an instance of solo, but that's now not possible because it's now private. So what you then do is you create a variable that you are going to use to store that instance. And this is what you do here. Create a pointer to store the instance. Now, one key thing I want you to understand on this pointer here is that it's static. And why is it static? This is very important to understand why we make the pointer static, right? And we make it static because it must be instance independent. Your variable must not be owned by a particular instance, which means if we make 5 objects of type solo, they must share exactly one solo instance. So that is why we make this data member here static, because it must not belong to a particular instance of solo. It must be shared across all the instances of solo, which means anytime we see an object of type solo, we know that it's using this exact same instance, right? That is why we make it static. And the last thing that you do is you then expose a function that you are going to use to give whoever wants an instance that instance. So this here is also static. Why? Because you see in the next slide that this function requires access to this variable, because this function is merely just returning this instance. But because this is static, this is also required to be static. So in other words, we can talk about two reasons why this becomes static. Number one being, you can't use a static variable inside a non-static function, right? So because this function requires access to this static member variable, it also has to become static, right? So because we can't use a static member in a non-static function. And the second reason why we make this function static is we need to be able to call this function without requiring an instance of solo, right? So second reason, so we can call it without instantiating solo. So these are basically the two reasons that we can think about why this also has to become static. So basically you have to understand why your variable here is static and why your function is static, right? The second thing I want to talk about is declaring a static variable. Whenever you declare a static member variable in your class, this isn't really like the declaration. This is more like a forward declaration, which means we haven't really defined it yet. We are simply telling our class that, well, you've got a static variable called only instance, right? The actual declaration happens in your implementation file. So here we are simply talking about how do you declare static variables. It's more like you declare them twice, once here and once in the implementation file. But besides that, these are the three things you have to do when applying the Singleton design bit. Number one, hide your constructor. Number two, create a member variable to hold that instance. And number three, expose a public function that can be used to get that instance. So in terms of the declaration, these are the changes that you have to apply to your class, right? Now, the next thing is, how do you implement? The first thing is declare a static variable, right? Which is why I said this is more like a forward declaration. So to make this look clean again, it just looks like that, right? But this is more like a forward declaration. The actual declaration is what you then do here, right? And it follows the same convention that you use when doing your functions. In other words, what type is it? What is the name of the variable? In this case, remember, in your implementation file, you always prefix everything with the class name, double colon, whatever it is, like you do on your constructor, like you do with your functions, everything, right? So that is exactly the same thing you are also doing here. You are prefixing your variable name with the name of the class. Otherwise, it's a normal declaration like solo instance. And here we are declaring and initializing it to a noun. But remember, we have to put the class prefix there. So this is very critical to remember, that it's not any fancy syntax. It's a normal declaration, only that you are prefixing it with the class, which is the convention for everything that you do in your implementation file. Our constructor remains whatever it is, which means if your class is doing other things, nothing needs to change, okay? Also here, if you had any other functions that are here, you don't need to touch them. Your focus is only on these three things, right? And now, implementing your get instance, it's very simple logic. Check if the instance has been initialized yet. If not, let's make a new instance of Solo and let's keep it in this point. And let's return it. If it has been initialized, the second time we call this function, this obviously will fail, so it will skip this and it will just return that instance. So it's very simple logic to remember. Has the instance been initialized yet? No. Okay, let's initialize it with a new instance. Otherwise, this will skip and we return it. So when it comes to implementing your singleton, there isn't much. Declare a static variable, implement your function, and that's all. Now, the last thing is, how then do you use this class once it's singleton? So here, remember, it is now forbidden to do something like this. Solo s equals new solo. Why? Because the constructor is private, so it's not accessible here. And the same goes for something like this as well. If it's not a pointer, this also cannot be done. Why? Because the constructor is private. You cannot access it. The only way to get an instance is to use your get instance function. And remember, one common example is where they say, what's wrong with this? You declare a variable of type solo, then you call get instance. And obviously what's wrong is the fact that you cannot even do this for a start. This is not possible because the constructor is private. And this explains the second reason why this function has to be static, because we want to be able to directly call the function on a solo object without having to make an instance first. So this is how you get an instance of a singleton function, a class. You simply call the get instance function directly on the object, or on the class rather. That's how you get an instance. And you can do this anywhere you want. All these instances will be using exactly the same instance, which means any changes you make anywhere are reflected everywhere else because it's just the same instance. It's the same instance. So to explain this, let's look at this example here. It's a whole question from one of the assignments. This had to do with students and managing marks for students and graduating and all of that. So there's a whole lot going on in this question, but it doesn't matter. You can obviously read through the whole question to actually understand what was going on in this question. You can do that. I'm not going to explain what this question was really about. No. What's important is the part of this question that focuses on one of the classes called student list. And they said, ensure that there can only be one instance of this list. This is what tells you that you are applying the singleton design pattern. Because the moment you have to restrict to one instance, then you know I am applying the singleton design pattern. All right? So that is how you would know. Anytime you do the question that says instances, restrict instances, immediately you know you are dealing with the singleton design pattern. So now to understand how easy it is to implement singleton, I've got the solution here, right? You actually ignore everything else and you focus on the one class that you want to convert to singleton. And in this case, it is this student list class. And literally, I just follow those three steps as they are. Number one, identify my constructor and make it private. Number two, create an object or a pointer to store the instance. I can call this anything, only instance if you want. And number three, expose a function. So this has to be static. Expose a function to return the instance. And again, it's static. I can call this function anything. I can call it instance or get instance, and this returns a student list pointer. I have applied Singleton, just like that, right? The next thing obviously to do is our implementation, right? I have to declare this variable and implement this function. So if we go here, let's declare our only instance variable. It's a pointer of type student list. It's in student list and it's called only instance. I'm going to initialize it to no value. Now let's implement our get instance function or instance function. Again, it returns a pointer. It's called instance, called instance. And what does it do? If only instance is equal to a null value, what do you do? Only instance is equals to new student list. Otherwise, return only instance. And it's Singleton. So you can see that it's very easy to apply the Singleton design pattern. Now, if we build this solution, now you realize that it's going to fail everywhere else. We were getting a student list instance. And it's going to say, it's not private. It's not failing because there's nowhere else in this solution I'm actually using a student list, is there? There is. So this must actually fail. Why is it not failing? Clean this solution. Build it. There you go. So it was caching some of the stuff. So if we build this solution, you'd see that it's going to fail everywhere else we were getting an instance. And if we go to the widget class, you realize that we are requesting an instance here. And what is the error? It's going to the constructor and saying it's private, which means something is trying to use this constructor, but it's private. So the right way now is to remove this from our widget because only the widget is using this list and it's making an instance here. So now we take it away. And let's go to the implementation of this widget class. You realize that where are we using a student list? Here, we are using it. Where else? Here, we are using it. Which means every time we need an instance of student list, we can simply request that instance like this. Student list equals student list instance. And now this is a pointer, so dot exists here, dot get student. Where else do we use it? Here, we need one again. So let's make another instance. So I can request an instance everywhere, anywhere I want in my program, and I'm going to get that same instance. So you can see that here, I am just accessing it. So this becomes that. This becomes that. Where else do we need a student list instance? Where else are we using one? Here. Again, I can just request an instance. So the point is you can just request an instance anywhere in your program where you need an instance by using your instance function. And anywhere you request this instance, you're going to get that same instance. So you can add students in another function, request the instance in another function, it will be the same instance. Okay, so that is basically how you then do it. Let's see if there's anywhere else. Here we do want one. I can do that, and I can just go like that. Where else do we need one? I think that's all. Let's now build it. Okay, we still need one here. Okay, let's put one there. There. And now let's build. And it's happy. So the solution will still work the same way it was working. We are not discussing what this was about. We are simply discussing converting the class to a Singleton class and making all the changes that we have to make. So at this point in time, you can see that anytime we need an instance, we use that function. And it will be the same instance. So it doesn't matter where I request it, I'm going to get that same instance. And that is how you do the singleton design pattern. Cheers.